All right, and we're on. Good morning. How hangover are you? I mean, it's good to see so many people here at Friday morning. I was about to leave, then Matt called me this morning, like, you have a talk, you know? So I'm here, lucky, just in time.
Yeah.
I'm Brian. I work for a company called Snyk, and we do some security stuff. Basically, we create developer tooling for developers to make security more easy. I'm working for the Utrecht Jug as well, and the Virtual Jug. We have a lot of stickers over here. Come afterwards, but that's about enough for me. But Matt, you were wearing that Hawaiian shirt that makes me...
Makes you want to be somewhere else, right?
Yeah, and it feels kind of hot, so I'll put this one off. Because, man.
So my name is Matt Raible. I'm a hick from the sticks. I grew up in the backwoods of Montana without electricity or running water. But somehow I ended up in computers. And now I work for a company called Okta. My dad calls it Okra, but it's actually Okta. And we basically provide authentication in the cloud. So we like to say friends don't let friends write authentication. And if you use Okta, chances are you can wear a shirt like this and, you know, feel like you're on vacation as a developer.
I think it's funny because how did your father call the company?
Okra?
Okra, yeah. We have this debate with Snyk. It's Snyk. The point is, it doesn't matter. Just it's how you like it. So now you know.
Right. And so one of the things that I wanted to do, because I've seen Josh Long do this, is I'm going to do a video selfie. And it was my daughter's birthday this week on Tuesday. So that's why I was a little late to Devoxx. So what I want y'all to help me with is saying, happy birthday, Abby. Right? Her name's Abby. So ready? We're going to
Don't get that wrong. Please.
Right. We're going to do a trial run. And if that one's good enough, we'll only do one. But we might have to do two. You ready? So I got to like selfie it. And then here we go. Ready? Happy birthday, Abby. I kind of sang that. That wasn't good enough. And let's a little more enthusiasm, right? Like, happy birthday, Abby! Like, I want it loud, okay? All ready? 1, 2, 3. Happy birthday. Nice. Thank you. She'll love that. All right. You ready?
Yeah, we're going to talk about Spring Boot, right?
We're going to talk about Spring Boot. So I love Spring Boot so much, I got some tattoos. All right? And you're a big fan too as well, right?
I am. That's why I'm here, but I'm not just...
You're not that?
I'm not a hipster. Come on.
I am a hipster. Java hipster.
I know.
All right.
It's up to you, man.
So
start up.
The first thing that I'd like to mention is we did write a blog post about this, and it wasn't Brian here. It was Simon that originally started this with me, Simon Maple. And so if you want to get a lot of the nitty-gritty details, we cover that in this blog post. And so there's a bit.ly URL at the bottom there that you can go and take a look at. But I just wanted to mention that so you know this isn't the only thing out there on 10 excellent ways to secure your Spring Boot application. So the first thing I wanted to start with is using HTTPS. And a lot of people call this SSL. And you may not know this, but SSL is actually a deprecated term. The official name is TLS, right? Transport Layer Security. And it's a cryptographic protocol that basically ensures secure communication over a computer network, right? Its primary goal is to ensure privacy and data integrity between computer applications. And as of July 24th, 2018, Chrome now labels HTTP sites as not secure. So there's really no reason you shouldn't be using HTTPS these days. And a lot of that is because of Let's Encrypt. Let's Encrypt makes it very easy to use free HTTPS certificates. It used to be if you bought an HTTPS certificate, it would cost, you know, hundreds of dollars. If you got a wildcard certificate, for instance, for star.okta.com, that would cost you thousands of dollars. And now that's no longer the case. You can get both of those for free. And you can use CertBot to generate certificates, so that makes it very easy to add new ones to your application. And if you're even doing local host development, I've seen several people that recommend using TLS for local host as well. And even in JHipster, we have a profile for TLS that generates a certificate for you and has it running, you know, with HTTPS by default. The reason people recommend that typically is because you never know what can differ between production and your development environment, so you want to have development match production. And then MakeCert is great for that. So MakeCert can actually generate localhost certificates, and it adds it to your local root certificate authority, so you really don't have any browser prompts that say, hey, this isn't a valid certificate. And there's also a Spring Boot Acme starter. So that automates, getting new certificates. For my personal site, raibledesigns.com, my provider has set up a cron job that goes out and gets me a new certificate every 30 days. So you really don't have to worry about creating certificates a whole lot. And this is a great site that I just came across this week. This is from Simple DNS. It's howhttps.works. Yes, that is a valid URL, .works. And so it's a great site that just shows how a cat would explain HTTPS. So it's a comic, and it's even fun for kids. So if you're using Spring Security, and I hope you are, to force HTTPS, one of the things you can use is in the Web Security Configurer adapter, you can say requires channel.any request and requires secure. So that's how you can force it for your local host or production. But what I found is sometimes it's nice to just use localhost with HTTP and then just force HTTPS in production. So this is a way that you can do it on providers like Heroku or Cloud Foundry. They pass this header through that says, hey, continue using HTTPS, or it started with HTTPS, so continue it on the back end, and that works great right there. So the second one, I'll turn it over to Brian.
Yeah, it is scanning your dependencies. And as you know, you probably pull in, if you create a Spring Boot application, you pull in the Spring Boot starter, for instance, and some other kits. But that's not enough. Basically, what you do is you grab more, because you do not want to write everything yourself, right? But as you may know, there was a problem, I think it was 3 years ago, with a company called Equifax. They had a thing. I don't want to talk about the company itself because they were just a victim. But in 2017, they had a system that incorporated Struts 2. And Struts 2, as you may know, has a vulnerability. But the point is, if you don't know that, and you're up in production, and you think everything is fine, you might get breached. And that's what happened to Equifax, to be short. And if we look at how that happens, once this vulnerability was disclosed, it was just in the first few days that people tried it out, because afterwards it was quite vastly fixed. There was a new version out that didn't have that problem. But if you don't scan your stuff, or you don't know it, or you don't get alerted that the stuff you have in production is vulnerable, you just continue. And if you have a legacy application, for instance, you might be vulnerable because you're using older libraries. The point is, if this is your application, who was in my talk yesterday, then you have seen this one. Don't spoil the quiz questions. If this is your application, this is probably your code, because you depend heavily on these frameworks, right? You don't want to create yet another CRUD repo or something like that. You want to focus on your stuff that makes your company or makes your product bigger, better, and stronger. So we've got let me get rid of this one. We got a serverless example over here, and it has 19 lines of code. It is JavaScript, because it's easy to mock JavaScript, of course. It has 2 dependencies, which one of is AWS SDK. It's turned out to be 19 dependencies, which is not that bad considering it's Node, right? But the trick is, how many lines of code do you put into production? Any clues? Silence.
Shout it out.
No, it's not 1 million.
100,000?
Almost. It's almost 200,000. 191,155 lines of code, which is scary because basically you just put in somebody's stuff and you use it. You have no clue what's happening there, right? And if you look at the dependencies, for instance, for NPM and Maven, the problem is not the things you put in, but dependencies depend on other dependencies. And there might be a problem underneath. So you have to scan, and not only to see if the dependencies you pull in are good, but also if the dependencies underneath are not a problem. For instance, if we use that, why not go into your system and connect your repository to a scanning tool, so you can actually easily scan your system. If I do it over here and I go into a project, I use my own tool, of course, but there are many tools to do this. But I want to show you how easy it could be, because if I have my GitHub repo over here, and I have my GitHub repo connected. And for instance, well, let's say I do zip slip because the name zip slip is already a vulnerability itself. And I will add that repository. It will add that repository and will scan it for me. And you see that over here we have this, and you see that my POM XML already has 12 high vulnerabilities. And let's go into there. And I can see that, for instance, well, why not fix it here? Well, we have a pull. We can create pull requests from there. So if you have these scanning tools available, it is not so difficult anymore for your boot applications or your Spring applications to be sure that it can be fixed. I can open a fix PR and it will go back to my repo, which is convenient, I guess.
Super convenient.
That looks good, right?
Yeah.
All right. So let's get back to the presentation.
Oh, so one of the things we wanted to include is this is kind of a hacker-related session, right? So we had some life hacks that we wanted to give you today. So, you know, you can go and hack your own life and make it a little better. So how many people have holy socks? Right? Maybe you have a hole in your sock. Maybe you didn't get some from a vendor. Well, one of the things that you can do is instead of fixing your socks, you can actually just paint your toenails. And then people actually don't see, you know, your
It's kind of like patching, but
right. And you don't really even need like toenail polish. You can use just a Sharpie. That works just fine there as well.
yeah, I think that's a good one. So if all the security things do not work for you, at least you can fix your socks now.
You fix your toes. Socks are fine. Keep the holy ones. All right.
I was talking about dependencies and libraries, but what you can do as well is simply update your libraries. And that is easier said than done, of course. But if you go for Spring Boot, how do you start with Spring Boot? Of course, you go to Josh Long's favorite website, start.spring.io. Oh, I think it's his second favorite. His favorite one is production, of course. But to go there and choose the last version that is generally available. That is the first thing you should do. Because if you do that and you build on top of that, you at least know it is as secure as possible. But you need to upgrade afterwards, right? Just staying on that version will not be convenient. And if you do that regularly, it is not that big of a problem. Because if you look at your dependencies, you have to look, I mean, the Spring dependencies, fair enough. There's a company backing that up. There are great open source maintainers to do that. But what other dependencies do you have? How did you get to them? Did you just look on Stack Overflow and copy paste them in? Who did that once?
I've done it multiple times, not just once.
Yeah, me too.
Stack Overflow is like my lead developer on my team.
I'm not a developer. I'm not even a developer. I mean, I just copy paste Stack Overflow and hope it runs. It is called, well, what was it called? Hope-driven development or something like that.
Yep.
But you have to look at these dependencies, right? Are these dependencies still maintained? Are there regular commits on that? Why should I use that one? And do I already have something in my POM file that does this? I was working for a bank before, and literally I was scrolling through the Maven dependency list, and we had 4 different marshalling libraries for XML. I was like, why? And I asked one of the maintainers, or one of the other developers was like, yeah, we needed to build a new function, and I had no idea how the other 3 work, so I put in a 4th one. Like, but is that good practice? Of course not. But that is the thing you should take care of. And if you do that regularly and you use dependencies that are well maintained, well known, and still, for instance, how many of committers are there? How many people are working on this actively? When was the last commit? These things you should take into account. And of course, you need to upgrade. If you have NPM, why should you? But probably you need to do some front end as well. There are some simple things in your package manager that can help you to see if there are newer versions available of the library you already use. The same holds for Maven. If we do a display dependency updates, it can show you if there are newer versions of a certain dependency you're using. So this way, if you do this regularly, you can see if there are newer versions and you might want to upgrade or not. And if you keep upgrading regularly, not like every other year, but say every other week or every other month, and it are just small increments. Same holds for Gradle. There are things available in your package manager that can help you out. Why not use them and maybe even automate that inside your build, like, okay, we have newer versions. Maybe that if you want to be top notch, maybe even break your build at that point, right?
Right. So the next one is CSRF, enabling CSRF, cross-site request forgery. And what CSRF, I don't mean to enable it so people can hack it, I mean to enable CSRF protection, right? How CSRF usually works is someone maybe gets a cookie from your site, or they embed a small image in your site, and then they can actually perform actions on behalf of that user back to your web application. And most people are like, well, what can they do? Well, what if there's a change email feature in your website, right? And they can change, you know, Matt Raible from using Gmail to using their email address. And then guess what? They can go and talk to my bank and do a password reset. And they've, you know, rechanged their email to mine, and now they get the password reset notification. Now they can drain my funds, right? So most people don't care about, you know, security or anything until you learn that someone can hack your bank and take your money away, and then you're like, whoa, yeah, I don't want that to happen. So how you can do that with Spring Security is it's pretty easy. You'll just go CSRF, and then the only reason it's enabled by default. So you see a lot of people when they talk about, you know, REST APIs built with Spring Boot, they'll have http.csrf.disable. And that makes sense if you're doing, you know, just REST APIs and you don't have any forms or anything in your web app. But typically, I like to see it enabled. And then if you're doing like a React front end or an Angular front end, and maybe it even sits on a different port, maybe it's deployed to Netlify, and then your back end is deployed to Cloud Foundry or something like that. What you can do is this CSRF token repository with HTTP only false. That allows that React or that Angular front end to read the CSRF cookie. Without that, what happens is by default, Spring Security will put it in an HTTP only cookie, which means JavaScript can't read it. And so in that situation, you got to turn it off, which isn't a great thing. So using this will allow that client to read it. If you're using Angular, it already understands that cookie that comes across, and it transforms it to a header and it sends it back. If you're doing React, I think there's a library you have to add, or you can, you know, hack it yourself to just read from that cookie and then send it back as a header, and then Spring Security will understand that. So you had a life hack here.
I got a life hack. Well, you travel a lot, right?
I do, yep.
Do you ever get takeout to deliver to your hotel room?
Right, it's convenient, right?
Yeah, right.
Especially
I just do like Uber Eats or something,
Right.
order a pizza. But most of the time, it's late at night, and I'm not American, so I cannot like take the whole pizza. I always have leftovers.
My son can take a whole pizza down.
I'm not. But you have the point, like, some people like cold pizza in the morning.
Right.
Do you?
I prefer it warm, right?
Yeah, prefer warm. How do you do that when you're in a hotel room? That's difficult, right? How do I warm up my pizza? Do I go downstairs, or do I just create a pizza oven myself? I mean, this is a life hack. I need to, if I want to do breakfast with a pizza, with my leftover slice of pizza, I mean, this is available.
And I think it'll work late night when you get home from the bars as well. Right?
Exactly. You do have to look out. I mean, normally when I come back late at the bar, late at night from the bars, I'm not that sharp anymore. But it could work. I mean, late night snack.
I'll try it.
Actually, yeah, you should, man.
So the next one we'd like to talk about is what's called a content security policy. So CSP is the abbreviation for that. And a content security policy will basically allow you to restrict what people can put in as far as third-party scripts into your websites. Most of us build really nice websites that are clean and fast. Even if we're using Angular, React, or Vue or something like that, chances are that everything loads quickly. We have lazy loading configured, and everything works really nice. And when people talk about local storage and it being a vulnerability, most times you're like, I really don't have a problem because no one can really access, you know, scripts or anything in my local storage. Well, that's great when you go to production, but then what typically happens is marketing gets involved. And marketing's like, we need to add all these tracking scripts so we can, you know, see who's coming to our website and what they're doing. And so when that happens, that's where your third-party vulnerabilities can come in, and then they can access local storage. So with the CSP, what you can do is you can restrict who can do what. And so these are the default Spring Security headers. If you just configured Spring Security boot starter in your pom.xml or your build.gradle, this is what it'll send back by default. So you see it's doing some things like denying X-frame options, and XSS protection is there. but it doesn't actually produce a security policy by default. So what you can do is there's a convenient way with the Spring Security DSL where you can say content security policy, you know, the script source has to come from this application. It can't come from anywhere else. But oh, by the way, I do have this trusted script. Maybe it's, you know, the Workbox plugin for doing service workers with Google. And, you know, here's my report URI that sends, you know, what my CSP does. And so that's a nice way to do that, easy to configure. You can also actually do it with an HTML tag in, like an index.html, and you can configure it similar in there with a meta tag. And then once you do that, you can use securityheaders.com to actually scan your site and see that you've set them all correctly. So this is from a coworker of mine. He has sudo binbash.com as his website, and you can see he has a content security policy set up. There's a new one out there called a feature policy, refer policy. So those are all, you know, really good security headers to have set, and you'll get an A+. And so chances are you could run this on your company's website right now and see how they score, and hopefully if you're a security company, it does well. And then Federico Hakamin, the guy who had that sudo bin bash website, this is a blog post that he wrote on how he converted it to do that. And a lot of the times I've even converted my RaibleDesigns.com to use a more robust content security policy, and I didn't have to change a line of code. I just talked to my provider, my ISP, and said, hey, I want an A+, and he did all the work. So you can probably have someone at your company or your provider do all the work for you. And you can see he started with a D, and he went to an A+. So, went too far. Sorry, too much.
Yeah, now you spoiled it.
Spoiled it. You didn't see that life hack, though. We'll be fine.
Because, I mean, you know, we're working from hotels or conference rooms, and sometimes you have this part like, okay, we can do application security, but how about your network?
Right.
I mean, maybe the Chinese or the North Korean are involved and spying on you. How do you, when you travel, how do you take care of your network security?
I don't know.
I mean, the input stream is also important. Like, start from the core, right?
Yeah.
So I found this awesome hack, which you and I and everybody can use to secure your input stream. I mean, just use a rubber, right? Now we have a secure stream of data flowing in. So now you make sure that if viruses or Trojans are coming in, you are protected.
Nice.
Yeah?
Yeah.
I tried it. It worked. Nobody got in.
So the next one I wanted to talk about is using OpenID OpenIDC for authentication. So OpenID Connect is what OIDC stands for. And this basically came from the need for authentication with OAuth. So if you're not familiar with OAuth, OAuth is a way of doing delegated authorization. It has nothing to do with authentication, or at least it didn't until OpenID Connect came along. So what happened was, back in the day, I don't know if you used websites in like 2005, 2006, you probably used like Yelp.com or LinkedIn.com, and as soon as you finished signing up, they prompted you, and they said, please give me your Gmail or Yahoo credentials. And it didn't just say, like, enter your Gmail address. It said, give me your Gmail username and password. And for the most part, probably we did it, right? And then what happened was LinkedIn would go out and get all of our contacts and then send them all an invitation, right, to join LinkedIn. And there was no guarantee that LinkedIn didn't keep that password. You know, maybe 30 days later, they tried again and scan your contacts again and send another one. So this gave rise to the delegated authorization problem, right? In the sense of, we wanted to give websites access to my contacts, but I don't want to give them my username and password. So OIDC and OAuth came along to solve that. But what happened with OAuth, basically after you did this flow to give access, all that the application got was a string. And now a lot of providers use JOTs, JWTs, so there can be user information in there, but for the most part it's just a string. That's all OAuth requires, and so there's no user information. You're like, great, they can access it, but who are they? So that's where OpenID Connect came along, and this is the flow. So if you're on Yelp.com, you'll click Connect with Google, and you'll go to their authorization server, and that can be accounts.google.com, it could be Facebook, it could be your Okta account, and you'll send some information. You'll send a redirect URI that'll come back, right? It's a URL you're going to come back to. It's got some scopes in there, and then you request consent after they've logged in. And as far as the login on authorization server, that's not part of OAuth or OpenID Connect. That's whoever the provider is. They handle the authentication. And then it comes back to your redirect URI. It has an authorization code. And so that'll be in your browser. But that authorization code's only good once. You'll send that back to the authorization server to get access tokens and an ID token. And so that's part of OpenID Connect. The scope OpenID, that's the only difference between it and OAuth, is if you're doing regular OAuth with no OpenID Connect, there's no OpenID scope that you pass in. So once you pass that in, you've magically flipped on the switch to OpenID Connect. You get back that ID token, and you could read that ID token and show it right there, or you can actually go to what's called a user info endpoint and get the information from there as well. And so with Spring Security 5.1, they added excellent OpenID Connect support. And why it's so important and why it works so well is because there's an issuer URI. You can go to that issuer and get all the endpoints that Spring Security needs to do the authentication, to do the token exchange, to figure out who the user is. And then you pass in a client ID and a client secret. And the only way to get a client ID and client secret is you actually register at a service. It's like going to the DMV in the US, we call it the Department of Motor Vehicles. You go and register your car, you get a license plate. That's the same thing here. The client ID is a license plate. So you can show your license plate to anyone. It's not really a big deal. The client secret, you don't want to store in source control, right? You want to keep that outside of source control, maybe as an environment variable, maybe even locking it up a different way, which we'll get to. And then you could do, authentication just with something like this, easy, groovy code. And so, has anyone used the Spring Boot CLI? Wow. Okay. I'll show you this real quick. So we got a terminal up here. Make it a bit bigger, and then I'll grab this code. All right. And then I'll do, we'll do it in a different directory here. So make dir devoxx. This is a different keyboard, so I will make mistakes, but hopefully we'll still make it work. So we can do OIDC.groovy. All right, we can put that in there. And that's, what this will do is it'll use the Spring Boot Starter OAuth 2 client, and it'll force us to basically log in to even access that home page. So all I got to do is figure out how to quit VI. It's the hardest part when you're on a different keyboard, right?
Man.
There we go. All right, and then you'll create like a application.yaml. YML. And then if we go back here to the previous one, right, we have this whole bit. Actually, I don't even need to do that. Luckily, we, let's see, shift, there we go. We practiced this beforehand, so I'm just going to grab one that I already had. Oh, it's so hard. So, Devoxx 19.
Slash groovy.
Groovy?
That's Devoxx 19 / groovy. There it is.
There it is. We'll put that one right here. And then if we cat that, you can see I put the values in. Please don't look at my client secret. Don't memorize that or anything. I guess it's already on YouTube, so I'll have to delete that app. But if I ran Spring run, it's a problem with streaming it live, right? So you can just run that, and it'll actually, start Spring Boot. We don't have a pom.xml. We don't have a build.groovy or anything, or a build.gradle, and we're up and running. So then if we go back to our browser here, open a new tab, get out of full screen so we can see what we're typing. Localhost 8080. Come on, baby. And it'll prompt me to log in.
Hard.
It's hard, right? And it comes back and we're logged in. But you'll notice what it says is hello, some weird string. So this is actually bringing back from the security principal. All right, if we were to cancel this and look at OIDC.groovy, you can see it's just hello user.name. So that comes from the security principal. And if we want to get more information, you got to do, for instance, the full name. You do principal how.attributes.name. And that gets you the user's full name. So if we run that again, then instead of seeing, hello random string, you'll see hello Matt Raible or whoever your user is. So that's how that works. And Spring Security provides all that, right? There wasn't anything Okta specific in there or anything besides Spring Security. So that works nicely. And you could also do it with Java. And the cool thing is with Spring Security 5.2, there's actually, you can pass in an authorized principal, @authorized principal as an annotation. And then you can cast that to an OIDC user. And then you can get all of the attributes from that. And you can get users' information as well. So the roles that they're in, and Spring Security will automatically map the roles that they're in or the groups that they're in to the actual roles. So it works with Spring Webflex as well. I wrote a blog post on that. I like to write blog posts. And then it works with JHipster as well. So, you know, I did say that I was a Java hipster. On to you.
Ooh, that looks great.
All right.
Talking about hashing your passwords. I mean, first of all, you can use Okta or any other provider to do that. But in some cases, you cannot. You need to do it yourself. But you don't want to have plain passwords, plain text password in your system, right? I mean, have you ever tried to write up into a system, to write on, to connect to a system, and then you forgot your password? If you say forgot password, what does it give you back normally? Probably a link to create a new one, hopefully. I always try that out to see if it does, because if it brings back my password, then I know it's somewhere there, or it is not securely stored. They know my password, basically.
Right, you don't want that.
Try that out. If you have a website and you can push forget your password and you get your password back, don't trust it. Because what we want to do is we want to make sure that your password is hashed. And that is that every time I hash the same password, I get the same hash. So, for instance, 4 times I hash the word TSD, which stands for the secure developer, because, well, that's what we are, right?
That's what we are.
And it gives you back exactly the same deterministic hash. So what we can do is just save that hash and make sure the next time you use a password, we hash it again on the fly and just compare the 2 hashes. So we do not know what your original password is, as we shouldn't know. I mean, first of all, there is a GDPR thing, but second of all, I don't want to get caught. If somebody gets these hashes, it's not a big problem, because first of all, we need to make sure that these hashes cannot be transferred back into a password. That's the beauty of a hash. It's a one-way encryption. But you shouldn't use normal hashes. A normal hash is quite quick and works super fast. That's something we do not want to have with password encryption. We want to use a specific, strong cryptographic hash. And the fun thing of that is, it is quite a slow algorithm. And it might go over that password multiple times to get a certain hash, say 10 times, 20 times, whatever. The point is, because it does take a fair amount of time, and not like 1 millisecond, but maybe 10 milliseconds, it's still feasible for your system, but not for somebody to brute force hack it. That's the thing. So you have to make sure that you use a password hash algorithm that is strongly cryptographic hash algorithm. And every password should have a hash that is non-predictable. So we have to look into algorithms that are useful for you. Not just your plain MD5 thing, of course, but we do not want to have collisions. That's the first thing. But the second thing is that if you see the hashes, if there is a pattern in it, I can guess what the next one will be. So there needs to be a one-to-one mapping. Fair. We talked about that. But what you have to be sure of is that you use the right password encryption encoder. If you use Spring Data Security, then we can simply insert a password encoder like this. Spring Security already has these encoders in itself. We have bcrypt, and more stronger, the follow-up from that is scrypt. By using scrypt in this way, and I just created a bean over here, I can insert that bean anywhere, and I can simply encode my password to the right standards. Scrypt, and both bcrypt and scrypt in Spring both have automatic salting, and well, it is a strong cryptographic hash that you should use. Nobody, in my opinion, should write their own algorithm because cryptography. So that's a hard word. Cryptography is a hard thing to do, and I'm a programmer. I'm not somebody who's in cryptography. So use these things that are available. But what you should do now, at this point, AskCrypt is good enough. It's strong enough. But you should review this and keep reviewing this because what's good now may not be good tomorrow. And you see, by just inserting this bean and using it inside your password hash algorithm, you can simply switch these things out for newer versions, and you don't have to bother about it. It's just there.
And Spring Security actually has something that they added in 5.1 where you can have an upgrade flow of the password hashing. So they will allow you to log in with your current MD5 or whatnot, and then it'll upgrade you to using something like AskCrypt or even Argon 2 as a password encoder. And the Spring Security CLI or the Spring Boot CLI, you can type Spring and code password, and then give them a password, and they'll encode it for you. So that's a convenient.
It's even with Spring Security, it's even possible to use multiple encoders if you want to. So multiple different encoders. And so you can choose, or you can choose if some parts of your system are not that heavily important and some are, to have a stronger or weaker password encryption. So that's your life hack.
So this one's great. And I believe it actually works. You can use a piece of raw chicken and clean parts of your vehicle. I've tried this on one of my Volkswagens, and it works awesome. It'll pick up everything, and then you just wash off the chicken and cook it. Right?
But how do you get rid of the smell?
I don't know about that.
Or you just like the smell?
Yeah,
you like the smell. Okay,
right?
Fair enough.
It's fried chicken if you put it on the heaters.
Oh, just fry your car afterwards.
There you go.
Okay, using secrets, that's the next one. Because although we encrypt our passwords and we still need to make connection to databases, we still need to make connection to other systems. We might need to store JWT or JOD or whatever you call these weird things. Secrets are important, and we do not want to have these secrets as plain text in our system, right? So if I Google for remove password, or I do that on GitHub, I have a lot of people that commented, I removed the password, or I recreated the password, or new password in it. And that's convenient for me as if I was a hacker, right? Because these tools like Git, they have something that is, well, how do you say that? That is good for development, but also good for me as a hacker. I can see the history. And I can probably find out, if you didn't burn the history, what your previous password was, and maybe what your new password is. So you don't want to have these passwords end up into your, well, open source repo. That would be even worse. If it's your private repo, then it's already a thing. But if it's open source and it's out in the open, you don't want your passwords to be in there, or your whatever secret. So what you can do is you can use tools, for instance, like Git Secret, that help you with that. They simply scan your commit and see if there are secrets in it. They pattern match to things like passwords or hashes that you might not want to have in your Git repo. It can force you to, or it can break off your commit, so it will not get into your Git history, and so you do not end up with these things inside your Git. There's also tools like GitRob. There's another one that can scan your Git repo if there are secrets there, or were secrets there. So that helps you to get these secrets out. And if you get these secrets out, just make sure that you also burn that history part. So you rewrite that history. Not getting stuff out of the code is not that bad. It's not that hard. But to make sure that it's also out of the history, then you probably need tools to help you out with, because I'm not that much of a command line Git user. I can do Git commit and Git push.
Git rebase. It's worth your time to learn. Then you can delete commits and stuff.
Oh, Git rebase. Yeah, and then delete all and start a new one, right?
That works too.
But how should we work with secrets? Well, you probably have heard of things like HashiVault. A vault is something central where we can manage and store secrets, because we might want to switch out these secrets, and HashiVault is a good way to use that. But to use that inside Spring, we have Spring Vault. And Spring Vault basically is an abstraction, a Spring abstraction, which use HashiVault under the cover. And by simply importing it, we have the ability to connect to a HashiVault instance and use the secrets from there inside my system just by using an annotation. And by doing this and porting this to my, or pushing this to my Git repo, I do not have the secrets there anymore, but I have my Vault to manage this stuff. And if I need to manage this stuff, I even can ask for temporary stuff there. Okay, I want this password to be there, and it only is valid for 30 seconds, which is good enough for automatic logins or logouts. Same holds for JUTs or for other hashes that we need at the moment. So just like we said for OpenIDC, use something to manage this for you if possible. And there are even possibilities to use this on-prem if you're not able to use the SaaS solution. But by using this with an annotation, you do not have to care anymore.
And so this was some advice that I had, and that's testing with Z-Attack Proxy. So this is an OWASP project, and how you can use it is to actually set it up so it scans your website. You'll set up like a network proxy in Firefox or Chrome, and you'll browse through your site, and then you'll go ahead and replay it with Z-Attack Proxy. And it has two different approaches. One is a spider scan, and one's an active scan. So a spider scan, you just feed it some URLs, and it goes through and tries to, crack those. If there's forms on the page, it tries to submit them, things of that sort. The active scan is where you use Firefox or Chrome, and you set up this session where it proxies to Z-Attack Proxy, and you actually go through and you enter your username and password, maybe you go fill out some forms, and then it goes back and tries to hack your site. So I did this a while ago, and you can see it gave me a whole bunch of alerts there, cross-site scripting, directory browsing, right, if people can see the files when they hit a directory endpoint, parameter tampering, secure page browser cache, like all those different warnings that it gave me. And, it took me probably maybe an hour to fix most of them. A lot of them, they tell you how to fix them, and you can go ahead and do that. So that works really nicely. It's got a long URL for the homepage, so usually it's just easier to Google for it. But it's a Java client, and it works quite nicely. You can also contribute to it on GitHub there, and you can follow it on Twitter.
Yeah.
So the last thing was
the last one
yours.
is security reviews. And who does code reviews? The rest of you does pair programming? Fine. No, but tell me, what code do you review? I mean, you have to make sure that the right person reviews the right code, right? If I'm, as a developer, needs to review a cryptographic new implementation of whatever hash, I'm not perhaps the right person to do so. So I think for code reviews, you have to make sure that you indicate which parts of your system are vulnerable or are heavily into security. So you can use the right people in your company to do that particular review. So we wrote a top 10 on what you should look for if you want to do a security review. First of all, you need to identify and validate third-party inputs. And it's not only inputs directly from the user. It's not only the text fields, because that is quite obvious, but also things like, okay, if I use an import from another database, maybe that can be compromised. But also if a user inputs a file, for instance. If I go to, if I can insert a zip file, so let me go to an example. It's somewhere over here. I think it's in the exploits folder. Yes, so I have a zip file over here. And you think of a zip file, okay, cool. We have a zip file, it has a path, and we put it into a public folder. But if my zip file looks like this, which contains two files, just a normal file, but the second one has a path reversal in it, it can be vulnerable. I mean, if you do not check it yourself, because in Java we do not have a library that zips and unzips for you. We have the building blocks, but you cannot do it like on the spot. There is no package in the JDK that does that for you. We have third-party libraries that can do that. But if you do it yourself, do you check your path, or do you simply trust on it? And that might not be your first thing in your mind to do so. but you should check every single thing that a user can input. So every input can be dangerous. That's one thing you should take care of, because if this happens, and I can demonstrate it later on a Heroku instance that I override something in the JDK, because that's just possible. Going back to my slides, and we will go back to that top 10. Well, we talked about not storing credentials, so you have to look for that as well. Testing security vulnerability, third-party open source dependencies, we talked about that. But also authentication of inbound requests. Like, who is there? Do I trust this person? How did he not only authorize, but is he also able, or is he the one that can manage that endpoint? Can he or she, or that instance, can that? Did I implement the least privilege principle, for instance? Oh, that's number 5. So cool. Whitelisting over blacklisting. For instance, if I do that path traversal and I just say, okay, .. is not possible. Well, that's okay for .. but if I use password encoding, then we're done. So if I use whitelisting, what is possible, I have all things that can be vulnerable, or all things that can actually hack my system. I have them out and only have that small portion of things that can be in. Well, handle sensitive data with care. We talked about the secret storage, but also about the things like making sure that you use the right hashing algorithms. It also holds for things you need to take care of, like personal data. Some things you just want to store in your system, but make sure you use a correct algorithm, in this side two-way algorithm, to store these things, and not only store things in plain text. Well, these are a lot of things. We are working on a cheat sheet on this, so keep a look on the Snyk blog to these topics, because we think in reviews it happens that people review it like, yeah, it sounds good, looks good to me, commit. Review takes approximately 10 minutes, but writing the code was like hours. So why not review carefully, and not only review on specific things like speed and maintainability, but also on security issues. If you want to know more about Java security coding, so that little blue spot in that bigger ring, we created a cheat sheet to see what the most vulnerable things in Java are. For instance, some things are very reasonable, like path traversals or things like SQL injections, but also things like external entity availabilities in your XML parser. Take a look at it and use it also as an input for reviewing your code.
So to recap, 10 excellent ways to secure Spring Boot. Feel free to take a picture at this point. But even better, Snyk has a security cheat sheet for Spring Boot as well. So you can see at the top there's the Spring Boot security best practices. Has everything we talked about today, a few little code samples. And yeah, we encourage you to not have security that people find lacking. So it's a great shirt. If you can get one, you can wear it in the airport, and you know, TSA loves it.
Have you ever been to Tel Aviv or to Israel?
No, I have not. I've been told not to wear this shirt there.
Try it. It's fun. They've got a good sense of humor over there. Trust me.
And the last life hack, and this one actually works. I tried it out last night. So thank you for coming. We enjoyed our time here, and follow us on Twitter. We'll make sure and upload these slides on the speaker deck after this. And yeah, appreciate it. We also have a whole bunch of stickers down here. If you're interested in JHipster stickers or some Snyk stickers or Secure Developer, come and grab some.